Hello everyone, this is Dr. Surya. So today's problem is, if the 5-day BOD at 20 degrees Celsius of waste is 150 milligram per liter and the reaction rate constant to the base at 20 degrees Celsius is 0.35 per day, then the ultimate BOD in milligram per liter is dash. So this is the problem. So first we will write. So what they have given is 5-day BOD. So which is I can write it as Y5 at 20 degrees Celsius. So this is given in the problem as 150 milligram per liter. Then the reaction rate. So reaction rate to the constant which is K is equal to 0.35 per day. So they have asked us to determine what is Y0. Y0 is nothing but my ultimate BOD. Since because the temperature is given as 20 degrees Celsius, we can straight away take down the formula and we can use it off. So the formula will be Yt is equal to Y0 into 1 minus E power minus Kt. Okay, so here T denotes your 5-day BOD. So we can rewrite it as Y5 is equal to Y0 into 1 minus E power K value is 0.35 and again my T value is 5. Okay, so I know all the values except Y0. So Y5 is going to be 150, Y0 into 1 minus E power 0.35 into 5. So the value for Y0 will be 181.55 milligram per liter. That is my ultimate BOD is 181.55. The next problem is the 5-day BOD of a wastewater sample is obtained as 190 milligram per liter and K is equal to 0.01 per hour. The ultimate oxygen demand in milligram per liter of the sample will be dash. So this will be as such our previous problem. So they have given our 5-day BOD, which is my Y5 will be equal to 190 milligram per liter and K is equal to 0.01 per hour. So we have to see this. So it is given in hour. So generally the reaction rate will be given in per day. Okay, so we have to convert this. So which is K will be equal to 0.01 into 24 because 24 hours make a day. So I have to multiply by 24. So generally you have to see the unit conversion. That is the most important thing. And they have asked us to determine the ultimate oxygen demand, which is going to be Y0. So we can use the same formula, which is Yt is equal to Y0 into 1 minus E power minus Kt. So here Yt will be Y5 and Y0 value is the one we have to determine, 1 minus E power minus Kt. Okay, so Y5 is 190, Y0 into 1 minus E power, instead of K I have to write 0.01 into 24 and again the T will be 5. So now my Y0 value will be 271.89 milligram per liter. So the answer will be 271.89 is the answer. The next problem is, a portion of wastewater sample was subjected to standard BOD test. So standard BOD test means itself it is 5 days at 20 degrees Celsius and it yields a value of 180 milligram per liter and the reaction rate constant was taken as 0.18 per day. Okay, the reaction rate constant at other temperature may be estimated by Kt is equal to K20 into 1.047 T per minus 20. The temperature at which the portion of other wastewater sample should be tested to exert the same BOD is 2.5 days. So this is the problem they have given, which means they have given Y5, that is 5-day BOD at 20 degrees Celsius is given to me in the problem as 180 milligram per liter. Okay, and they have given our K 20 degrees Celsius as 0.18 per day. Okay, and they have asked us to determine Y 2.5, that is the BOD at 2.5 days at the temperature T. So what is my temperature? At what temperature I have to see it out, because they have given the same BOD. So same BOD it is going to be 180 milligram per liter. But after 2.5 days, what will be the temperature? This is what they have asked. So first what we are going to do is that we are going to determine the ultimate BOD. So ultimate BOD is the one that is going to remain the same, and using that only we will be determining what is the temperature. Okay. Say for example, the formula will be y phi is equal to y naught power 1 minus e power minus kt. The same formula we are going to use it of. So which is y phi is 180. 1 minus. So which is y naught into 1 minus e power minus 0.18 into t. That is going to be 5. So using this formula, I will be getting my y naught value was 303.32 milligram per liter. So first thing is that I am determining my ultimate BOD. But if you check, the temperature is going to be different for other thing. So say for example, so that we have to determine our KT value also. That is a reaction. For reaction rate, the temperature is going to be different. So because the temperature is different, so instead of y phi, I am writing it as y 2.5 is equal to y naught into 1 power minus e power minus kt into 2.5. So note down the difference. In the previous case, if you see that the formula is going to be y phi is equal to y naught into 1 minus e power minus kt, and the generalized formula will be yt is equal to y naught into 1 minus e power minus kt. So this T denotes our BOD. Okay. So now if you see in this problem, they have asked us to determine for 2.5 day. So I am rewriting the formula as y 2.5 is equal to y naught into 1 minus e power minus kt into 2.5. So the reaction rate constant is given for 5-day BOD, when we do not know the value of 2.5-day BOD. So that is we are going to determine what is the reaction rate constant, because using that only we can determine our temperature. Okay, and they have given, because they have given the same BOD in the problem, my y 2.5 will be 180. Okay, and y naught we have determined already, that is my ultimate BOD is 303.32. 1 minus e power minus kt, and the BOD is 2.5 days. Okay, so using this I will be determining my kt. The only unknown is going to be the kt. So kt will be equal to 0.36 per day. Okay, so if I have determined my kt value, then it is going to be easier for me to determine my temperature. So the formula for that is kt is equal to K20 into 1.047 T power T power minus 20. Okay, so KT value for 2.5 days is 0.36, and K20 is given to be in the problem as 0.18 and 1.047 T power minus 20. So if you see here, all the values are known to me. The only unknown is going to be T. And by rewriting the formula, I am writing 2 into 1.047 the whole power T minus 20. Okay. Because it is in power, what we have to do? We have to take the ln. So ln 2 will be equal to T minus 20 ln 1.047. By substituting this, I will be getting my T value as 35.09 degrees Celsius. So the answer for this question will be the temperature at which the portion of other wastewater sample should be tested to exert the same BOD at 2.5 days is 35.09 degrees Celsius. And this is the answer. Thank you. Happy learning.